cycle, like we've learned in our story, Wild Weather, last week. So it can start anywhere. It just goes around and around. So when it rains, precipitation. Remember, precipitation is anything that falls from the sky. Rain, sleet, hail, and snow are all precipitation. Then it collects. It collects in streams. It collects in puddles. It collects in ponds. It collects in rivers and oceans. So it collects on the ground. And then the sun comes out and it evaporates. So can we see the water going up? Why can't we see the water going up? Why, Cooper? Gas. It's gas. That's right. When it evaporates, it's gas. So it's going up into the sky. But when it gets up into the sky, it's no longer hot. It starts cooling down. And we do what's called condensation. Evaporation turns to gas. Condensation turns it back into water because it cools down. Remember, you need heat to make it evaporate. You need cool weather to make it condense. So condensation, and then it starts forming clouds. See all the little water droplets in the cloud? And then when the cloud gets really heavy, it comes down as precipitation. And then it collects again, and then it evaporates again, and then it condenses again, and then it falls again, and then it collects again, and then it evaporates, then it condenses, and then it falls as precipitation. Okay? So that's what we call the water cycle. Storms brewing. About 2,000 thunderstorms are sweeping across the globe while you read this book. So right now there's 2,000 thunderstorms about in the whole world. Thunderstorms are rainstorms with lightning and thunder. So if it's just raining, that's not a thunderstorm. It has to have lightning and thunder. They can strike almost anywhere, on land or at sea. However, the area around the equator, that's the middle of the globe, that big, like the belt that goes around the globe, produces the most thunderstorms. This region is called the tropics. The tropics have plenty of warm, humid air. This is the main ingredient for brewing a thunderstorm. So here's tropical Africa is the lightning capital of the world. So there's some elephants in the lightning storm. The warmth of the sun causes water to evaporate to form water vapor. Warm, damp air rises, and as it does, water vapor cools and condenses to form clouds. If a lot of damp air rises rapidly, the clouds may form a flat-topped cumulonimbus cloud. Remember, that's the big tower cloud. Cumulonimbus clouds are thunderstorm factories, and inside them, water droplets combine to form larger drops, and soon the drops become too heavy to float in the air, and they fall as rain or hail. So here's a cumulonimbus cloud. Big, 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 tall cloud. A bolt of lightning is a huge electrical current. So we have electrical currents going through all the wires in our house to run our lights and our switches that we plug things in. But a bolt of lightning is like a huge current, like what's inside those wires. Electrical currents flow when positive electrical charges, that's the plus signs, and negative electrical charges, that's the negative signs, are drawn toward each other. Where else did we see plus and minus or positive and negative signs? Something we learned about. No? In magnets, that's right. So it's kind of like magnets with the plus and minuses. So when they're drawn toward each other, remember you had to have a negative and a plus to make the magnets attract? You couldn't do it the same sides. During an electrical storm, clouds, air, and objects on the ground all become charged with electricity. The top of a storm cloud often acquires a positive charge. So here it is. Here's the top of it. It's a positive charge. Okay? The bottom is negatively charged. This causes particles in the surrounding air to become charged as well. So charged particles make excellent conductors. So if you have it on the top and the bottom, you have a lightning inside a cloud. So this is inside a cloud lightning. If you have plus in one cloud and minus to the other, then look, you have cloud to cloud lightning. Have you ever seen it go across the sky? Lightning? Yes. But most of you have probably seen it go from cloud to ground. And that means it's plus up here with minus on the bottom, and there's lots of plus on the bottom. Now the cloud to cloud, inside a cloud one, is kind of like when you see the clouds look like they're lighting up inside them. When you look up, it looks like the clouds are lighting up inside. That's inside a cloud lightning. So those are 3 types of lightning. Yes, Wyatt? Yes, you see plus and minuses on batteries. That's exactly what we're talking about here. Because that's energy too, right? Batteries are energy. Charges particles make excellent conductors. Objects on the ground then acquire a positive charge. The stage is set for cloud to ground lightning. When the difference between the positive charges on the ground and the negative charges in a cloud grows strong enough, lightning strikes. An electrical current flows through the air. Lightning and thunder are a team. Lightning causes thunder. Did you know that? Lightning is what makes it thunder. Thunder is the explosion that you hear when the air is heated by the lightning. Lightning is really hot. So when it goes from cloud to cloud or inside a cloud or down on the ground, it's so hot that it makes an explosion in the air. You can't see an explosion, but that explosion makes a sound. Explosions make sounds, right? So that explosion you're hearing from the hotness of the lightning hitting the air makes thunder. The air can reach 50,000 degrees Fahrenheit. 50,000 degrees. That's more than 5 times hotter than the sun's surface. This extreme heat causes molecules in the air to expand and vibrate, and the vibrations create the boom of thunder. Lightning and thunder occur at almost exactly the same time. But if you see a flash of lightning and then you hear the thunder, light travels nearly 1 million times faster than sound. The sound of thunder travels 1 mile in 5 seconds. So the next time you see a flash, count the seconds until you hear thunder and divide that by 5. So if you count 10 seconds between the time that you saw the lightning and hear the thunder, that means that the storm is 2 miles away. Because for every 5 seconds is 1 mile away. So if you count, you see lightning and you count 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000, 6, 1,000, 7, 1,000, 8, 1,000, 9, 1,000, 10, 1,000. Then you hear the boom. That means it's 2 miles away. Isn't that pretty cool? Can you kind of tell how far the storm is? Oh, look here. This is about the lightning rod. Some buildings have lightning rods onto them so that hopefully the lightning hits the lightning rod and doesn't hit anybody or hurt the building. Let's see. I think that might be all I'm going to read out of this book. Yep, that's all I'm going to read about this book right now. I just want to talk about that. So, that's about how thunderstorms are. Isn't that pretty cool? It's plus and minus charges in the sky.